All right, we're on Chapter 10, Section 3, which is Learning Plan 5.9, and we're dealing with logarithms. A logarithm is an exponent. We're going to convert between exponential and logarithmic forms. We're going to solve equations that log base a of b is k. Solve them for a, b, or k. Graph logarithmic functions, and then use logarithmic functions in exponential growth and decay type models. Okay, a logarithm is an exponent, like I just said. So we've got the different parts. The logarithm is the exponent, the base is a, and x is the answer. So logarithm is an exponent. The expression log base a of x represents the exponent to which the base a must be raised to obtain the power x. Now, an exponential and a logarithmic function are inverses of each other. 3 to the second is 9. 1/5 to the negative second is 25. 10 to the fifth is 100,000. 4 to the negative third is 64. All right, so let's fill. Whoa, are we missing something? There we go. So let's fill in these forms and see what we get. So 2 to the fifth is 32, means log base 2 of 32 is 5. 100 to the 1/2 is 10. Log base 8 of 4 is 2/3. 6 to the negative 4th is 1/1296. All right, so write 6 to the third in log equals 216 in logarithmic form. So log base 6 of 216 is 3. 64 to the 1/3 is 4. This is, notice, is the exponent. The logarithm is the exponent. All right, so let's look at this example, and we're supposed to solve this equation. In other words, what number, 3 to the negative third is what number? Well, 3 to the negative third is 1/3 to the third, which is 1/27. So x is 1/27. You do this one. Oops, this is the same kind of a thing. 1/3 to the second is 2x plus 5. 1/3 to the second is 1/9 is 2x plus 5. Subtract 5 from both sides, which is 45/9. So negative 44/9 is 2x. X is negative 22/9. Dividing both sides by 2. This one, x to the 4th is 5. Now we would take the 4th root of both sides. 4th root of both sides, plus or minus, because it's an even power. So x equals plus or minus 4th root of 5. This one, 36 to the x is 4th root of 6. Remember, to solve these, we have to get the bases to be the same. So this is 6 to the second to the x equals 6 to the 1/4. So 6 to the 2x equals 6 to the 1/4. 2x equals 1/4, so x is 1/8. Solve these four. So 2 to the -5th is x, so 2 to the -5th is 1/32nd is x. Change colors. 3/2 to the 3rd is 2x minus 1. 3/2 to the 3rd is 27/8 is 2x minus 1. Add 1 to both sides, that's 8/8. So 2x is 35/8, so x is 35/16. Next one, I'm going to change colors again. X to the 2nd is 10. Take the square root of both sides. Remember, it's going to be plus or minus square root of 10, so x is plus or minus square root 10. Last one, better change colors one more time. 125 to the x equals the cube root of 5. This is 5/3. 5 to the 3rd to the x equals 5 to the 1/3. 5 to the 3x equals 1/3. So 3x is 1/3. X is 1/9. Next one. Properties of logs. Anytime you have a number, the base and the exponent are the same, then the exponent must have been 1. Anytime you have a number to the 0th power, you get 1. So log base 12 of 12, we're supposed to evaluate. 12 to what power is 12? Well, obviously, that's 12 to the 1st. So we would say that's 1. Whenever these two are the same, the answer is 1. Whenever any number, any base to the 0th power is 1, any base to the 0th power is 1. So how do you graph these logarithmic functions? To graph them, we're going to, first of all, we need to rewrite this as y equals log base 4 of x, or in other words, 4 to the y equals x. So if x is 1/16, that's 4 to the -2. If x is 1/4, that's 4 to the -1. If x is 1, that's 4 to the 0th. If x is 4, that's 4 to the 1st. And if x is 16, that's 4 to the 2nd. So at 1/16, we're at -2. At 1/4, we're at -1. At 1, we're at 0. At 4, we're at 1. And at 16, we're at 2. So you see it comes in like this. Boy, that was not a very steady hand. You try this one. So 6 to the -2nd is 1/36. 6 to the -1st is 1/6. 6 to the 0th is 1. 6 to the 1st is 6. And 6 to the 2nd is 36. So back or forward 1/6, 36 down 2. Forward 1/6 down 1. Forward 0. Or forward 1 up 0. Forward 6 up 1. And forward 2. Or forward 36 up 2. So our graph is going to come in like this. and then take a violent turn down. Okay, x is 1/10 to the y. Now, how does that work? Well, 1/10 is, 10 is 1/10 to the negative second. 1 is 1/10, any number to the 0th power is 1. 1/10 to the first is 1/10, 1/10 to the second is 1/100th. Okay, so over 10 down 2, over 1 at 0, over 1/10 up 1, over 1/100th up 2. So it's going to graph like this, which leads us to, oops, you do this one. 1/4 is 4 to the negative 1. Any number to the 0th power is 1. This is 1 and this is 2. So at 4, we're down 1. At 1, we're at 0. At 1/4, we're at 1. And 1/16, we're at 2. So it's going to come in like this. And it's going to finish like this. So it'll always contain the graph 1, 0. If a is greater than 1, it'll rise like this. If a is between 0 and 1, it'll fall like this. In no case does it cross the y-axis. The domain is from 0 to infinity because it'll never be 0. And the range is from negative infinity to positive infinity. So how are you going to use this? Population of mites in a lab is growing according to the function p of t is 80 log base 10 of t plus 10, where t is the number of days after the study began. Find the number of mites at the beginning of the study, so that's where t equals 0. P of 0 is 80 log base 10 of 0 plus 10. Well, that's 80 is log base 10 of 10. Log base 10 of 10 is 1. 80 times 1 means there were 80 mites at the beginning. After 90 days, we could have pressed that on the calculator too. Let's see here. Clear. We could have said 80 times log. Oh, does this calculator even have logs? My wife told me it's not a very smart calculator. There it is. Log base 10 of 10. And you get 80. Okay, let's do the second one. After 90 days, P of 90 is 80 times log base 10 of 90 plus 10. Well, 90 and 10 is 100. Log base 10 of 100 is 2. 2 times 80 is 160. You could have pressed that on the calculator too. 80 times log, 80 times log of 100 is 160. T of 1, so G of 1 equals 15 plus 2.00 log base 10 of 1. Log base 10 of 1 is negative 1. Let's see. No, it isn't. It's 0. 2 times 0, so T of 1 is 15. Let's check it just to make sure. 15 plus 2 times log of 1 is 15. Okay, let's do the second one. G of 10 is 15 plus 2.00 times log base 10 of 10. Log base 10 of 10 is 1. 2 times 1 is 2. 15 and 2 is 17. Let's press it on our calculator just to make sure. 15 plus 2 times log of 10 is 17.